already. So this is the last kind of topic that we're going to be working with. We're going to be working with these rational expressions, and then on the back I'm going to be working with these rational equations. So make sure you're using those notes that you had from factoring. Again, we're looking for those products and sums. So again, products and sums for factoring. Again, make sure you're setting those up very carefully. So what I'm going to have is this. I'm going to have, when I have for number 15, make sure it's on the screen, I'm going to have two sets of parentheses since our degree or power of our polynomial is 2. So I have two sets of parentheses for each of these expressions. And so what I can do is I'm going to use those products and sums like I talked about. Again, make sure you can watch those other videos if you need to review, but it's super simple. We're saying, okay, I need two numbers that multiply together to get 4, whose sum is 4. So I'm going to say x plus 2 times x plus 2. Again, if you're ever unsure, you should be able to FOIL it out and get your same expression. For the bottom one, I can say I have same sign since our product is positive, and I'm going to say 6 and 2 for that one. For the top right, let's have different signs, excuse me, different signs since our product is negative. And so I'm going to have, let's do it like this. I'm going to have two numbers that multiply together to get 24, whose sum is 2. So I can say 6 positive and negative 2, since, actually just kidding, not negative 2, let's say negative 4. There we go, a little bit better. Since our sum is positive 2 and our product is negative 24, so we know we're good. In the bottom, this is the difference of squares. That means it has to be the same number. So I have x plus 4 and x minus 4. So again, make sure you're seeing how those are set up, be able to review if you need to for those factoring. So you should be able to crunch those out really simply. Make sure that you are able to do that. So what's the next step? We have to simplify. So we're going to cancel out. We're going to cancel out similar packages, meaning notice how I have an x minus 4 in the top and I have an x minus 4 on the bottom. So I have to have one in the numerator, one in the denominator, and they have to be exactly the same to be able to cancel them out. So I do that one at a time. So I have an x plus 6 in the top, x plus 6 in the bottom, x plus 2 in the top, x plus 2 in the bottom. Whatever's left over is going to be my answer. So I have x plus 2 over x plus 4. Make sure you write your restriction. Again, we're saying, okay, look at your denominator. Whatever values would make it 0 is what we need to have. So I say x cannot be equal to negative 4. So again, make sure you're seeing those ideas that we have. For number 16, we're going to be adding these two fractions together. Make sure you're seeing this set up. So I'm going to say, hey, my new denominator, or my common denominator, is going to be these two multiplied together. Again, I don't have to FOIL them out because I can just use it like this. So x plus 1 and x minus 3. Now what I have to do is I have to multiply both of those fractions, so that way the new fraction is with the common denominator. So again, this is how I set it up. I know my new fraction has to have this denominator, and then what I can do is I can fill in the blanks. So I'm saying, okay, what do I have to multiply this package by to get this? Well, I need to fill in the blanks. I have x minus 3. Whatever I do to bottom, I have to do the top. Make sure when you multiply, if you need to, you can do your little box method for your distributive property. So I have 8 on the outside, and I have x and negative 3. So I have 8 times x is 8x. I have 8 times negative 3 is negative 24. So that's going to be what my numerator is. So again, notice that these are equivalent fractions. I know they look different, but all we did was we multiplied the top and the bottom by the same value, so that way we weren't changing the overall value, we're just changing how it looks. So we have our first fraction. Now we need to do a similar idea with the second fraction. So I have 2, and I have x minus 3. Multiply it by something to get our new denominator, so x plus 1, x minus 3. So what do I need to multiply by? Well, what's missing is that, so I have x plus 1 and x plus 1. Going to be able to multiply. 2 times x is 2x, and 2 times 1 is 2. So now that I have my two fractions, I'm going to combine like terms. So I'm going to say, okay, I have 8x plus 2x is going to be 10x. And I have negative 24, and positive 2 is going to be negative 22. That's going to be my new numerator once I add those two together. Still the same denominator because we have a common denominator. Make sure you can try to factor out if you can. So I'm going to say it's going to be equal to 2 times 5x minus 11. Sometimes it's able to factor out, sometimes it's not, but it's always good to check. Make sure you write your restriction. So I'm going to say x cannot be equal to negative 1, positive 3. So again, make sure you're seeing those setups for those problems. For number 17, make sure you're multiplying by the reciprocal because you are dividing fractions. So what I can do is this. I can make this into a multiply. So I'm changing this to multiplication. I'm going to say this is the same as this. So I multiply by the reciprocal. So I have x squared minus 4 in the numerator, and I now have x squared minus 9x plus 18. So again, make sure if you're dividing fractions, you can multiply by the reciprocal. So same setup as number, let's say 15. I have 2 sets of parentheses for each quadratic expression. So again, like so, be able to set it up. And so in the top left one, I need a product of negative 12 and a sum of negative 4. So I have x minus 6 and x plus 2. Bottom left, we already did that one. Top right, same sign since our product is positive. However, both of them are going to be negative since our, actually, just kidding, back it up. Again, make sure you are seeing I'm multiplying by the reciprocal, so I now have x squared minus 4 in the top. So I have x plus 2 and x minus 2. There we go. Almost messed up, but we got it. And then at the bottom, I can say I have x minus 3 and x minus 6. So again, make sure you're setting up like so. Again, be able to cancel out from the top and bottom one at a time. So I have x minus 6, top and bottom, x plus 2, top and bottom, x plus 2, top and bottom. Whatever's left over is your answer. So I have x minus 2 over x minus 3. And we say x cannot be equal to positive 3. For number 18, that should be a multiply. So that was a little bit of a typo, but we set it up carefully. So we have these two multiply together. So I'm going to say, all right, same setup as the last one. Again, 2 sets of parentheses for each of those expressions. Again, be able to factor very simply for yourself. So on the top left, I have x plus 2 and x plus 4. Again, I can always double check. 2 plus 4 is 6. 2 times 4 is 8. Bottom left, I have x plus 4 and x plus 5. In the top right, we have x plus 2 and x plus 5. And in the bottom right, we have x minus 3 and x plus 2. So again, use those tools that you had from products and sums to be able to figure out your factoring steps. Cancel out those like terms, meaning I have x plus 5 in the top, x plus 5 in the bottom. I have x plus 2, and I have x plus 4, x plus 4. Whatever's left over is going to be our answer. So I have x plus 2 over x minus 3, and we're going to say x cannot be equal to 3 again. Last couple ones at the bottom. Again, we're subtracting these fractions, so I need to have a common denominator. So I'm going to take the product of those two. So I'm going to say our new denominator is going to be x minus 2 times x plus 5. Can be able to multiply to get your equivalent fractions. So I have x minus 2. I'm multiplying it by something to get our new denominator. So x plus 5. What's missing? Well, it's that x plus 5. So that's what I'm going to multiply the top and the bottom by to our first fraction. Be able to distribute, so I have 7 times x is 7x. 7 times positive 5 is positive 35. So we have our new fraction like that. And we have our second fraction. Notice instead of having a minus sign between those two, I can just have a negative 3 on top. So that's what I'm going to have. I'm going to add negative 3 over x plus 5. Again, fill in those blanks. New denominator we know. However, we need to multiply the top and the bottom by x minus 2. So we have negative 3 times x is negative 3x. Negative 2 times negative 3, positive 6. Combine like terms between these two numerators. So we have 4x, and we have plus 41, all over x minus 2, x plus 5. Make sure you can write your restriction. So I'm going to say x cannot be equal to negative 5, positive 2. For number 20, since I already have this quadratic here, maybe I can factor that out and use that as our denominator. So I'm going to have x plus 2 and x plus 4. And notice, hey, I only need to multiply this second fraction by x plus 4 to have the common denominator. So that's what I'm going to do. So I have a negative 1 on top for this second fraction. I have x plus 2 multiplied times something to get our new fraction. So we have x plus 2, x plus 4. So that's what I'm going to multiply by to both top and bottom, x plus 4. In the numerator, distribute that negative 1, so I have negative 1x minus 4. And so this is going to be your new numerator. Again, I have my first fraction, numerator is 5, so I have 5 minus 4 is 1. And so my answer is going to be like this. I have negative 1x plus 1 over your denominator, x plus 2, x plus 4. Again, be careful. Some people kind of lose where I'm at. I'm just adding those two numerators together since I'm combining those like terms. Write your restriction. X can't be equal to negative 4 and negative 2. Be sure to follow for the last page.